So the CDC reported that every 1.6 hours there is some sort of pedestrian-related injury or even death due to an automobile. A lot of this is due to lack of visibility from the driver. We wanted to address that, and we thought of an idea to create an insole that generates power and is able to power a light and other functions for a runner, jogger at nighttime, early morning, whenever they're going, to help keep them safe. We wanted to make sure that it is comfortable, it is efficient, and it's able to withstand, it's durable, able to withstand movement and water, whatnot. So we have three main components. We have an insole, which is lined with piezoelectric discs. We have a charging coil for a battery, which is a backup. We have a docking station where you can place the insole onto to display data such as step counting and to charge your insole. And we have finally the light, which is on a clip attachment. And it is activated based on triggers based by the piezoelectric transducer. Hardware.
Go ahead and introduce us.
Oh yeah, sorry. I am Moog. This is Roderick, Fook, Peter, and Vincent. We're Athlite.
Athlite. So, our main focus here is safety for the user, for the consumer. So mostly we focus on the producing the LED light at night during running or walking. So our LED is triggered by the piezo. Whenever the users take a step on the piezo, it will trigger the LED. We're using fiber optic to make it more illuminate, more lights produced out of it, more visibility for the user. For the step counting, it's just an add-on option. It's not a main criteria that we start out with. So, but for that step counting, we did a lot of trial of running and walking, and it turned out to be about less than 10% of error that during running or walking. For the trickle charge, our main challenge for the trickle charge is the piezo is not producing a lot of current. We in the microamp. So to charge the battery, fully charge a battery, 150 milliamp battery, it would take over 100 million steps while walking, and 17 million steps while walking. I'm sorry, over 100 million while running, and 17 million steps while walking. So if you're running at 274,000 steps a day just to get a charge for a whole year. So the trickle charge, even though it does some trickle, but it's not enough to sustain the power for the microcontroller.
One of our challenges was that the piezoelectric discs are a bit cheaper quality, or they're not as efficient. We could look for more expensive ones, but the issue was that it becomes too expensive to buy as an insole. It wouldn't be worth it for a consumer. Right?
Any questions?
Were you able to do those calculations you just mentioned before you did the experiments, or did you discover them during the experiment?
We discovered them during the experiment.
Okay.
Were you able to get any information on the percentage of pedestrian accidents that are caused by visibility and the percentage that are just caused by inattention or in the bright daylight? Were you able to tell what?
We looked around, but we saw it was a bit arbitrary in how they had, because it's hard to track what the issue is. But they said a lot of it was due to lack of visibility, especially at nighttime and early mornings.
Right.
So what's your microcontroller doing in the application?
The microcontroller basically keep count of the step. It also flashed the LED when it's triggered by the piezo.
So the piezo doesn't have enough power to actually run the LED by itself. You have to have a battery that you trigger from
Yes,
that.
so
Okay.
the piezo is not generate enough current to
Light it up bright enough.
bright enough.
Okay, so you have to keep the souls charged all the time, basically, or enough charged so that you can run the light.
Yes.
Okay, so that's why you have to set it on this charger on this
Station,
thing?
yes.
Okay.
So if you'd have known what you know now about how much power you can generate from the piezo's, what would you have done differently when you approached the concept of this project?
We could have stayed away from piezos first of all.
Okay.
Because there's just not enough power to do anything except for step count.
That you're triggering.
We,
Yeah.
we could look into other motions.
Other alternative versions, we could try to implement, use a battery to power the whole system, still make it portable, add more functionalities. Because dealing with the piezos, we can't put more functionalities, you know, like Bluetooth and all that kind of stuff. Because we're going to drain the one small battery we're trying to use to power the whole system. So we could have done something else different, just not use piezos for it.
Do you think you could have researched this before you tried the piezo?
So yes, we did. We in the first stage of our research, we were able to light up the LED. So we thought we could somehow boost the signal, see if we can, you know, make it brighter somehow. But it just wasn't happening at all. We're already at the end, you know, past our halfway to turn back.
All right. Let's thank the team.